Hello, this is Mrs. Schaefer, and I just wanted to go through the 3.03, the gas laws lesson with you and share a little bit of information to help you out. As you're going through this, you can pause at any time to slow down or review the information that you need. We will be looking at the review sheet questions 8, 9, and 10, continuing to build on what we learned on with the gases with pressure, temperature, and volume. You can use this slide to help you. If there's an area that you're stuck on, make sure that you can go back in and find the information in the PowerPoints to help you answer these questions. So we have been talking about what happens to gas if you change the pressure or if you change the volume or the temperature. And so with that, now we're going to pull it all together and look at several laws. Before we do that, we need to make sure we understand what proportional and inversely proportional means. So you'll want to stop and make sure you have this idea down because we will be using it throughout the gas laws. We're also now taking that information that we had covered before, what happens to pressure, if you increase the volume, what happens to temperature, if you increase the pressure, or what happens to pressure when you increase the temperature. We're comparing all of that information now and combining it to create the ideal gas laws. But here is the graph of what each one of them looks like and whether they're directly proportional or inversely proportional. So that's the information again from our previous lesson. And now we're going to be looking at specific laws. Same information, we've already learned it. Now we're learning the specific quote rules about it and how also to combine it all to give us the ideal gas law. So we're going to be talking about the Boyle's law, Charles' law, and Gay-Lussac's law. They each discovered their information differently. So as chemistry advanced, different scientists discovered and proposed understanding and explanations about the properties of gases. And each has their own explanation that became a gas law. So we're going to be looking at these individually, and then we combine them to create an ideal gas law. Remember that you want to take notes and information for this material to help you out. Mass stays the same in everything, so it is considered a constant. And in each of the gas laws, there is one constant. Then you can take all of these ideas, Boyle's law, Charles' law, and the Gay-Lussac's law, and combine them into what's called the ideal gas laws. So Boyle taught that pressure and volume were inversely proportional to each other. Charles' law shows that temperature and volume are proportional to each other, and the Gay-Lussac shows that pressure and temperature are proportional. So as one increases, the other increases the same. And then you combine them all and you get what is K, or the constant. So we're going to be looking at each of those. The PowerPoints will have some videos in there to help you. You want to watch each of these videos. You probably want to even snip some of this information. We definitely like to have our definitions in words verbally, but it's also nice to see it in math and with pictures. So here we have the Boyle's law demonstration. You'll want to click on that video. And then that lines right up with the review sheet question number 8. Charles' law lines right up with question number 9. Here's some pictures. Like I said, you want to pause and go through them, but it's taking each one and helping us understand a little bit better what happens in circumstances. And then here's the Gay-Lussac's, and it shows it to use some pictures and some math for you there. And here's an application question to think about. So which is the best example that shows the relationship between temperature and pressure? A, bubbles forming in dough when it's heated. B, evaporating water. C, melting ice. D, bubbles on the pizza popping when they're cut. So it has to have an element of both pressure and temperature, not just temperature. So eliminate any that deal with just temperature. Then it has to do with when you are either increasing or decreasing temperature, or increasing or decreasing pressure. So which one is the best for that circumstance? All right, so as you go through this, you'll want to make sure, like I said, that you have this information in your notes. It is hopefully by the time you get to Class Connect session, you'll have a better understanding of this idea of how they work together. We have the idea of with Boyle's law that in a closed system, pressure and volume are inversely proportional when the temperature and the mass are going to stay the same. So as the pressure of an ideal gas increases, the volume decreases, would be an example. With Charles' law, there's some fun videos there, temperature and volume of an ideal gas are directly proportional one to another, and the mass and the pressure are held constant. So in other words, as the temperature increases, so does the volume. As the volume decreases, so does the temperature. And then the Gay-Lussac's ideal law, the temperature and the pressure of an ideal gas are directly proportional when the mass and the volume are held constant in a closed system. So as the temperature increases, so does the pressure. And this is an example of Gay-Lussac. As the temperature decreases, the pressure decreases. Or as the temperature increases, that's the cooking of the dough, the pressure increases. That's why our bread has bubbles in it, is the application of this law, the Gay-Lussac's law. As the temperature increases, so does the pressure. And then that caused the gas bubbles in the bread to pop, and that's what you get left over. All right, so there's going to be a fun practice that we're going to do in the Class Connect session where you can test out your understanding of this. Please don't hesitate to watch those help videos or ask any questions if you're not understanding. Have a great day. We'll see you soon.